All right. Welcome back to day 28 of data structures and algorithms. Um, I think am I live? Let me just make sure that I'm live now. Uh, content. Ah, I'm not live. Oh. What's happening? Hold on. Um, what's going on here? Okay, I'm live now, and right. I think I need to turn on my lights. All right, so let's go. Um, Today I'm just going to choose some random questions, maybe easy or even hard questions. All right, so let's start with I would say arrays, right? So um, let me see if I can choose any array question here. Oh, I did it to some. Kate, that's modest. I solved like a lot of array questions so far. Have I not? Okay, so these are the ones I solved. Let me solve this middle one to make the checkbox complete. Right, so I can then let me see. Ooh la la. Okay, let's take a look at this question. It says largest local values in a matrix. You are given an n by n integer matrix grid. Generate an integer matrix max local of size n minus 2 times n minus 2 such that max local I at nj is equal to the largest value of the 3 by 3 matrix grid centered around row I plus 1 and column j plus 1. In other words, we want to find the largest value in every contiguous 3 by 3 matrix in grid, right? So return the generated matrix. I'm not sure if I understood that question, but okay. Since it's an array and matrix, I think it's just like it just requires a logical reasoning to be able to solve this question. So here's an example. We have is this a 4 by 4 grid? This is 4 by 4. What is it? Okay, so it's going to be n by n integer matrix grid. Okay, generate an integer matrix local of size n minus 2, right? So if it's 4 by 4, then it's going to be 2 by 2. Okay. Let me just. YouTube is not receiving video to maintain streaming. What? YouTube is receiving video, right? Isn't it? I have. Oh my god. Open widgets. There's an error in this. Okay, it's back to good. I don't know what's happening, but yeah. So just close this. I'm not going to look at that. Oh, my stream bitrate is quite low today, and I don't. This is painful. Okay, so we want to generate. If our grid, our matrix integer grid is n by n. Then we want to generate n minus 2 by n minus 2 grid, such that the max local, right, I and j, right, in the row and column, right, is equal to the largest value in the matrix, in the 3 by 3 matrix. Hold on. Max local, such that max local ij is equal to the largest value of the 3 by 3 matrix in grid centered around row I plus 1 and column I j plus 1. In other words, we want to find the largest value in every contiguous 3 by 3 matrix grid. This is not a 3 by 3 matrix grid. I don't think I understand this question yet. Okay, so I don't know if I'm not thinking straight, but let's say we generated matrix grid, right? So we are given this grid. This is a 4 by 4 grid, right? And we want to generate an integer grid, which is like n minus 2, right? So it's going to be 2, so 2 by 2 grid. Okay, n minus 2. So max local, right? So this is the local grid that we'll have at the end of the day, our 2 by 2 grid in this case, right? So the max local so is equal to the largest value of the 3 by 3 grid, right? So the first item I and j, right? So first column, second column, I and j is going to be equal to the largest value in the 3 by 3 matrix grid centered around row I plus 1. What's the 3 by 3? We don't have a 3 by 3 grid here. It should be the largest value of n by n grid, which is our main grid. I mean, if you say 3 by 3, this is confusing, right? Or are we taking just 3? 3 by 3. So are we just taking like a portion of this, of the main grid that we are given? The grid length is going to be n, right? N is going to be superior or equal. Okay, so the largest value in every 3 by 3, right? So if we take 3 by 3 here, we want to find the largest value here and use it to create our grid, right? So I'm just thinking about this, right? So let's say, in other words, if no matter how big the grid we are given is, right, we always want to take, the largest value from a 3 by 3 portion of it. And so in this case here, our first row is going to have, so the first row and 3 columns in that row is going to be 9, 9, 8, right? So 5, 6, 2, right? 9, 9, 8, 5, 6, 2. And then we'll now have because here we are using 9, 9, 8, 5, 6, 2, so we are going to create a 2 by 2 grid. but the largest value here, the largest value in this case here is, so 3 by 3. Wait, how do we get the largest value? So the largest value of the 3 by 3 grid, the largest value of the 3 by 3 matrix in grid centered around I plus 1 and column J plus 1. I'm not wait, this is strange. The maximum local value that we add in our we are using the largest value to create our maximum local grid, right? So if we had I and j as indexes, let's say I and j is 0 0, right? 0 0, the largest value of the 3 by 3 matrix, is it matrix grid or matrix in grid? Okay, wait. Oh, okay. Centered around I plus 1 and column j plus 1. Okay. So grid is just our n by n grid, obviously. Okay, so I and j is going to be, ij here is going to be the largest value, right? Centered around row I plus 1 and column j plus 1. What's row I plus 1? Okay, let's say I is equal to 0, so it's going to be 1, row 1. Where is row 1? I mean, if we represented this as an array inside an array, this is not going to, row 1 is going to be here, right? And say row 1 plus 1, j plus 1. Now that was want to find the largest. Okay, I want to find the largest value in every contiguous 3 by 3. Okay, let me use this image, right? I'll just come here and put it here to explain quickly. So let me see. Okay. Oh. Okay, so here's this here, right? This here is the grid. This is the grid we've been given. It's an n by n grid, right? It's also a matrix, and this is what we need to return, right? Another n minus 2 by n minus 2 grid. Okay, now we have to look at a 3 by 3 grid. In this main grid here, we have to take a 3 by 3 grid and find which is the largest value in that 3 by 3 grid, right? So max local I and j, right, is equal to the largest value of the 3 by 3 matrix in the grid centered around I plus 1. So row I plus 1, right, centered around I plus 1. Okay, I plus 1 and column I j plus 1. I plus 1 and j plus 1. I mean, if we take a 3 by 3 grid of a 3 by 3 matrix from our main grid, right, it's going to look like this. So it's going to look, let me use a different color. I'll use like a, yeah. So So let's say it's going to look something like this. We are going to go all the way from here, right? Take everything here, 3 by 3, right? So 1 2 3. Yeah, so this is our 3 by 3 grid, right? That's our 3 by 3 grid, and we want want to create a 2 by 2 grid from it, right? So centered around what's max local. Max local is our new grid that will return, right? Our new matrix. um Max local I and j. Max local at I and j. What did they tell us I and j are? Well, I and j are obviously going to be indexes, right? So maybe I will represent the row itself, and j is going to be the column. All right. Max local I and j is equal to the largest value of the 3 by 3 matrix inside the grid, centered around I plus 1, right? And column j plus 1. So imagine j, you know, j is equal to 0, j and I is equal to 0, j is equal to 0, I is also equal to 0. So if we take j plus 1, we are going to have 1, right? And we know, let's say here, right, this here is going to be I'll just take this first value here, right? This first value is equal to what's this called? Is max local, right? Max local j and I, when j and I are both equal to 0, right? And it says, the question says, this max local I and j is equal to the largest value, okay, in every 3 by 3 grid. Sorry. Are we just taking like, are we creating 3 by 3 grid in every contiguous 3 by 3 grid? So I mean, the largest value in this row here is 9, right? Let's assume this is our first row. The largest value here in this row here is 9. The largest value here is 9. So let's say we added 9 here, right? Where do we get the next largest value? Is this still going to be, I mean, this is row 0, this is row 0, this is going to be 0, column 0, right? So j and I is going to be 1. What if we increase, right? What if we increase? Do we only increase j, right? J is going to be here. J represent the column, I represent the rows. It's going to be 9 in every contiguous 3 by 3 grid sites. Or we increase both of them, right? So I mean, if we had j and I here, right, they are both equal to 0, 0. When j equals 1, then we increase I as well, right, and find, you know, the largest value in this portion of the 3 by 3 grid, right? So let's say here now, right, at this point here, 9 is the largest value. Okay, when we increase this to this point here, right, when we look at this, so j, Okay, so when we are at this point I and j, right, we can look at this entire one here. Hold on. I think that's, we can look from where 9 is all the way. Let me use a different color so that we can look from here, right, from this point all the way down, right. No, it won't work that way. Okay, what if we are looking this way? What I and j is at this point here, right? The largest value, we can look this way. um hmm Interesting. um Yes, I want to look at this. So the output grid is going to be like this, yes. So every value in a column represents one item in the grid, okay. Right, okay. So we have 9 and 9. Alright, 9 and 9. Hmm. I mean, if we look into every row, right, we can compare with the, we want a 3 by 3 grid, right? So this is going 1, 2, 3. Largest value is 9. So in this case here, right, still first row, second column. This is going to be 9, and then 6, and then 2, right? So we know we are going to use 9 because 9 is the largest value in that case. So we come here again, we have 8. That's going to be our first because we are going to create 2 grid. Okay, so 8, 8, 2, 6, 8, 2, 6. We have 8, 1, 6, and then 4. We have 6. Oh, wait. This is interesting. Is there an editorial for this? Oh, okay, there is, but I'll not read it now. I'm just going to keep it like that for now. And this is what, 5, right? So if this is 5, we're going to create a 3 by 3 grid because we are doing 5 minus 2. And 5 minus 2, this is 3 by 3 grid. 3 by 3. We have 2 everywhere. Why is that? Why do we have 2 everywhere? Let's see, approach simulation. We are given an integer matrix grid, right, of size n by n. For each I, j in the grid, we need to find the maximum value in the 3 by 3 matrix. Wait, okay. Does that mean we take the first I and j value and look through the entire matrix to find which value is the maximum? let's say for instance, if we take this here, right, we have to look through the entire matrix here. So from this point all the way here, every other place. Is that how, that what this question is saying? Sorry. So we need to find the maximum value in the 3 by 3 matrix with the top left cell as I and J. Okay, IJ. The local minimums should be returned in a new matrix. The local maximum should be returned in a new matrix. Note that we need to add the value to the new matrix only for I and J values with a valid 3 by 3 matrix. Therefore, the size of the new matrix is always going to be n minus 2 by n minus 2. And the last two rows and columns in the original matrix grid are left out. Last two rows and columns, so here, right? That's not 2 rows and columns, but that's like 3 rows and 1 column. I'm thinking, well, hold on. So we will follow the process given the problem description to generate the new 3 by 3 matrix. The new matrix, sorry. 3 by 3 matrices cannot be created from the last 2 rows and last 2 columns as of grid. So we will iterate over the rows from 0 to n minus 2, okay, and columns from 0 to n minus 2 in the grid. Good. For each cell, we will iterate over the 3 by 3 matrix and find the local maximum value. This value will be stored in the new matrix max local. Yep. I see. So next we have to start from here all the way here. Look at this, and then we'll look at this again. Okay, not bad. So we have to demonstrate this step, and the creative step will reiterate over 3 by 3 matrix and add the value and add the minimum value to the max local grid. The maximum value, sorry, not minimum. Maximum value. This. So when we are looking at this place, right, the maximum value here is going to be equal to 9, and then we'll shift our 3 by 3 grid to the right, and the maximum value here again is 9. Alright, they will come down. The maximum value in this place is 8, and then 6 on this other side. So create an empty matrix of size n minus 2, n minus 2, n minus 2 by n minus 2. This will store the maximum values of all possible 3 by 3 matrices. Define the find max function, which takes the grid and the coordinate x, y as parameters. This function finds the maximum value in the 3 by 3 section of the grid where x, y is the top left. Okay, yes. Iterate over 3 by 3 matrix starting with the x, y as top left. Find and return the maximum value. Oh, okay. That makes sense. iterate over grid rows 0 n minus, iterate over the grid, right? Rows at 0 to, rows at n minus 2, and columns at 0 to columns at n minus 2, and for each cell 0 at 0j, find grid I and j. So you use find grid I. This find grid is just going to be the function that takes the coordinate of the grid and then finds the maximum value within that grid, right? So our grid is always going to be a 3 by 3 grid. Okay, so local element and store it, right? So find the maximum local element and store it in the matrix max local at position I and j. Okay, so let's see what's going on here. So we take in the grid for I in range. Max element is equal to 0. Mass element is equal to 0. The mass element is going to be, so for I, right, in range x plus 3, for j in range y plus 3. Max element is equal to the max element of the grid, between the max element and the grid, sorry. So range y plus 3, this is going to be the outer loop and this is going to be the inner loop. Return max element, the largest local cell, equal to n for I in range. Okay, so somebody is in the comment section, chat, sorry. Hello, which data structure? I think this is just an array question, right? There's no particular data structure that was used yet. At least I did not think about using a pointer or, a sliding window or stack, for instance, right? This is arrays and matrix, right? So it's the array data structure and matrix. Yeah, so that's what you use to solve this question. All right, no more questions. Okay, so let me, even after reading this question, I understood what they're trying to do, right? So in every case, we'll create a new so here's how we are going to traverse this grid, right? I'm just going to remove, oh, sorry. Okay, so we are going to go through the grid this way. We are first of all going to start from this point, right? We are going to get a 3 by 3 grid first of all. We are going to go this way, 3 by 3. This is our first 3, right? This is our second 3 by 3 grid. So it starts from somewhere here all the way to this point here, right? And then we'll have another 3 by 3 grid from here all the way to this point, right? Oh, let me use a different color. Okay, so this is going to be from here all the way down to this point, and back. Right, so it's going to look like that. Let me take this one, green. So I'm just going to start from here, tra la la, all the way. My hands are not straight. Anyways, yeah. So we have four 3 by 3 matrices to look at. At least four 3 by 3 in our grid, right? I don't know why they decide to use grid and matrices in this problem. It's quite confusing to me. So how do we solve this? This is I'll I'll remove back my grid marginalization and just take it one step at a time, right? So let's just do it this way. So let's say we had this as as our um our first input, right? Let's just take this part. Let's just take this part. What does this represent, right? Come on. I don't know why that is not, working the way I intended to. Okay. So here's our first grid that we are going to. I will not call it a. Here's our first matrix that we are going to look at, right? Now, if we take a look at this, right, it's going to look like this. So the actual input, right, is an array of arrays, right? It's just a matrix. Let me take here. So here we are going to have it like this. Here's the actual input. The table, the image was just visualizing it for us, right? So it's just a visual representation of what the actual thing is like. So here is it. Here we have okay. All right, so if we take this part like this, right, it means we are taking one minus one less, right, of every array to create our 3 by 3. So this part here, this first row here is this here, right? And this second row is this one here, and our third row is like this from here all the way here. The fourth row will be here from here to here, right? So and then this is going to represent the fourth row, right? So these are fourth row, second, first, third. Yeah, okay. 5, 6. All right. So in every one of these row, right, we can try to get the maximum. First of all, we'll get the maximum in every of this row. But each item in the rows, right? So the array within this main array is the row, and the item within the inner array is the column, right? So first of all, we want to represent a 2 by 2 grid, right? A 2 by 2 matrix. Sorry, a 2 by 2 matrix like this, right? So we'll first of all get the maximum value here, right, in this row. So we'll look here. What's the maximum value in this grid? What's the maximum value in this grid? And by this grid, I mean from this place compared to this one, compared to this one, and then compared to this part here, right? So we need to get each maximum at every point. So or we can't do it like that. We have to compare everything one step at a time. Wait, we are looking for. Let me check the editorial again. So the entire grid, you get the maximum. Entire grid, maximum where the matrix appeared, maximum where the matrix appeared. Hmm. Return the maximum. Well, we can select the. Let me see. Um. For I. I'm not sure I'm understanding this question, so uh, I'll leave it in the description. Uh, Copy this and put it here. This I was not able to solve. Leet code easy. I'm not sure if Leet code actually does their, you know, rankings very well, but and this question is actually an easy question, and with the solution I have in my head, right, which is to com- if I compared, hold on, if I had, if I'm looking at this matrix this way, right, so I'm taking the first three columns, right, in each row, and I'm looking for the maximum value in each one of them, right? So here, when I'm iterating, I have my first item as I, right, for the column, and then J for the rows, right? Or let's use it this way. Let's put I and J. So J for the rows, J for the rows, and I for the column, right? So in this grid, right? Grid. Starlink, no. Oh. This means I will go through each. each one of its item. But now if we're doing it that way, right, if we're doing it this way, it means we are comparing each item in this row, but we want to compare it with the next ones, right? Or we find the maximum here first before moving on to the next one, right? And find compare the current maximum we have before moving on, right? So we'll come here. So at J here, we'll first of all find the maximum here. The maximum in this row is 9, right? It's 9. The maximum in this second row here, when J increases, right? When J increases, this is going to be equal to 6, right? We found 6. And the maximum here, the maximum in this row here is going to be what? Is going to be 8. So J is here, this is going to be 8. So we have 3 maximum here. And I mean, we've not traversed the entire grid yet, so we need to go from here again all the way to this part here. So meaning in every iteration of the outer loop, right? This is definitely going to have a nested loop, or we can find the maximum in every 3 by 3 matrix, right? Like I did here, and huh. I'm not thinking about this question properly. Um, I don't understand it at all. I mean, how much of the is it? If we look through, wait, let me see what this says. Let's say we are given a grid of size n by n, right? Each element at I and j, right, in the grid itself. For each element, we need to find the maximum value in the 3 by 3 matrix with top left cells as ij. The local maximums should be returned in a new matrix, right? Okay. Note that we need to add the value to the new matrix only for I and j. Values with valid 3 by 3 matrix. Note that we need to add the value to the new matrix only for I and j values with a valid 3 by 3 matrix. Therefore, the size of our new matrix is going to be n minus 2 by n minus 2. N minus 2 by n minus 2. Okay. So is it that we're looking we'll be looking at, so if we did it this way, right? If we looked through each row, right? Like the way I did it here, the row, we first of all choose the first 3, right? Because we want a 3 by 3 matrix. In each row, we can choose a 3 by 3 matrix to create this vex grid here, right? This subgrid, I'll call it a subgrid from, this point here all the way to this point, right, and down, right. Then in this case, we'll look for the maximum value in each grid and compare to every other remaining rows, right. We'll look for the maximum value in each column compared to every other one. So the maximum here, right, at this point here, will be equal to 9. So we'll add it to our 2 by 2 grid, and then we'll move from the first one towards this point here, right, to form another 3 by 3 grid, right. So we'll have 9. We'll have um we'll have from 9 from this point here. Let me just change this color. We'll have from 9 all the way down here, right. We'll have from 9 all the way to this point here, right, and back, right. So we'll then look for the maximum within each column, right, and then each row compared to. So in the first column, the maximum here will still be 9. In this, in the first row, and compared to the 3 columns, right, the maximum there will be 9. The maximum in this case here is going to be equal to 6, right, because we have 6, 2, 6, and then this part here will have um we'll have 264, right. 264. 6 is also the maximum here, and we know our maximum is definitely going to be the maximum of these 3, right. The maximum out of these 3 is 9, so we'll place 9 here as our maximum, and we'll move our grid down, right. We'll move the grid down to this point here. So from this point, we'll move all the way to this point, which means we are starting from what? From the next item in the row. So 9. So we'll start from 8 here, right. Sorry, we'll move. We okay. Oh, I see. Let me start over again. I understand now. Oh, okay. This is all I needed to know. Oh, let me copy this. Okay, let's bring back the grid itself. Oh, I see what the question is trying to ask us now. This is okay. So here's what we're given, right. We are given a grid that contains n by n elements, right, and we want to form a matrix out of that grid that will be n minus 2 by n minus 2 matrix, right. So first of all, we need to get a 3 by 3 grid from a 3 by 3 matrix from our main grid, right. So a 3 by 3 matrix is going to be from here. Sorry. From here, from this point here, all the way to this point, right, and then from there all the way to here, then back, right. So this, okay, let me do it this way. So this is our first 3 by 3 grid that will form from our 3 by 3 matrix that we can form from our grid, right. This is our first 3 by 3 matrix. Now we'll look into this grid, right, and find the maximum in each row, right. So in the first row we have 9, 9, and 8, right. When we look at the array itself, let me bring this down. When we look at the array itself, right, here's what we have. Let me move this here. Here's what we are just looking at. So we are starting from this point, right, this point all the way here. So we are selecting 3 items at each time, right. We are going to select from here and stop at this point. Now you'll notice that there's one other, I'll call this a row, right, one other row left, but we are not going to take this now. We are just trying to create a 3 by 3 grid, because our 3 by 3 means 3 rows and 3 columns. So we don't want to, if we include 3 items from this place, then we are creating a a 4 by 3 grid, so we want a 3 by 3 grid, so we leave the last item there, right? So we'll then take, we'll calculate the maximum at in every row, right? In every column on each row. So here 9 is the maximum on this row here, right? We have 9 here, 9 9 9 9 8, right? So we'll get 9 as our current maximum, so 9 here, and then we'll calculate again this point. At this point we have 5 6 2, right? 5 6 2, and then 8 8 is our maximum in the last row, right? We want to create a 2 by 2 grid, or n minus n, right? N here is equal to 4, right? So n minus n, to find n is basically the length of one of the sub arrays, right? So it's going to be n minus n, so n minus 2, which is going to be 2 by 2 grid. So the maximum in this row, right? The maximum in this row here is 9. So the maximum in this row here is 9, so we'll use 9 as our current maximum, right? And then we'll go again, right? So now we found the maximum in this first row. Sorry, not we don't add it to our 2 by 2 grid yet. So 9 is our current maximum, so I'll put 9 here. In the second row we have 5 5 6 and then 2, right? So the maximum here is 6. In the third row we have 8 8 2 and then 6, right? The maximum here is 8, right? So now we'll compare these three, right, to see which one is the maximum, the biggest maximum, and that's going to be the maximum within this grid that we just created here, or this matrix here, right? This is going to be the maximum here, and obviously it's going to be 9. 9 is bigger than 6. 9 is bigger than 8, so we'll put 9 in our 2 by 2 grid. So we'll put 9 here, right? Let me first of all erase every calculation we did. So 9 is going to be our current maximum. So I'll erase that. I'll create our grid back again. So this is going to be 9. This is going to contain 9, right? This is going to be 9, and then we'll move the grid away from this point here. We'll move it towards this side. So we'll move it towards this side, right? From this point all the way to this point to create another 3 by 3 grid. So it's going to be like this, from this point to this point, from this point to this point, and then from this point to this point. Now if we look at this, right, the maximum on the first row is going to be equal to 9. The maximum on this second row is 6. The maximum on the third row is 6 again. So when we compare these, right, when we compare this, the maximum here is going to be equal to 9. So we'll use 9 as our maximum again. So 9 is going to be our current maximum. And then we go on, right? Now we'll move, we can't create any more 3 grids from this point here. So we've already exhausted the 3 the possible columns we can create from this particular row here, right? We've reached the end of this, so we move on to the next part, right? So we're going to start from here, right? We are going to start from here all the way down, right? So we are going to start from here all the way down, then we'll go this way, right? So we'll find it's going to be like this. So the starting point is going to be here to this point, right? To this point, and then from here all the way to this point. From here now, or that will not include the last row that we were not looking at first. So yeah, so then we'll calculate the maximum at each row. So I'll just take this here. So the maximum in this row here is going to be equal to 6. The maximum here is 8, and then the maximum here is 6. So between all of these, 8 is the biggest, so we'll put 8 in our grid, and then we'll do the same thing for the next 3 items, right? So we'll go here, from here all the way to this point, and then from here all the way here, from here now all the way to this point here. So which is going to look like this. I'll use a green color to represent that. So it's going to look from here, right, all the way to this point, right? And from this point all the way back. Let me just erase this. Oh my god. I didn't know I was going to do that. So I'll just remove this. Oh my, okay. Okay, so then we'll look into our green matrix, right, and find which one is the maximum. So when you look in this row, we have 6. This row we have 6, and then 2 is our maximum in this row. So what do we do in this case? So we have 2, 6, and then 2. 6 is the maximum, so 6 is going to be our last value in the matrix. And unfortunately, I couldn't figure this out earlier, and my time is up. So, but I'm just going to announce from next week going forward, right? I will start, studying linked lists. So I'll start working with linked lists, right? Linked lists, right? Linked lists. So, so far I've done. Let me just erase this. I started with arrays, right? Arrays and strings. Then I did a little bit. I did from there. I did stacks, right? Then you know after stacks, I did two pointers, and then sliding window. Now I will take on linked lists from next week going forward. So um yeah, my network is really bad right now. I'm receiving notifications, but today hasn't been a smooth sail, right? Um, you know, we need to figure out struggle sometimes, even though it's an easy question. I mean, I don't feel um I'm not a judge per se to know if this is actually an easy question, but I was just maybe not thinking really well about the solution. But I'm just going to go ahead and leave this, to code by myself later on. Um, I'll advise you guys that are watching to also do the same. Try to come up with the solution yourself, right? After listening to the explanation, try to solve the code yourself. All right. Thanks for staying through this stream, and I'll see you tomorrow. Bye.